Let's go to page 272. This lesson is 4.8, and this lesson is to perform congruence transformation. Okay, a transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. So you have the original figure, and you do some kind of transformation, and the result you get is called the image. Okay. And it says the order of the vertices in a transformation statement tells you that P is the image of A. So P is the image of A, and Q is the image of B, and R is the image of C. It says there are three main types of transformation. A translation moves every point of a figure the same distance in the same direction. A reflection uses the line of reflection to create a mirror image of an original figure. A rotation turns a figure about a fixed point, called the center of rotation. So here's example. So here's your reflection. Reflection means you flip these things over. Okay. So example of that would be like if you have object over here, reflection would be like flip it over. Okay. And rotation is there's a point of rotation. So I'm going to use this point as rotation, it's easier. So this is a rotation. Okay, so again, this reflection means flip it over. Rotation means you rotate the object. And translation means you slide. So when you move over, that's a translation. Okay. Now the translation doesn't have to be horizontal. Translation can be like in diagonal like that. Okay, so translation can be like this. Okay. And the rotation does not have to be on this point. Rotation can be based on this point. So when you rotate, it becomes like, like this. Okay. So again, there are more transformations, but right now we're dealing with only these three. So reflection, flip it over; rotation, you turn; and translation, you slide. Okay. Okay. So let's go to page 273. Translation. In a coordinate plane, a translation moves an object a given distance right or left and up or down. It can use a coordinate notation to describe a translation. So this one, notice you slide over and up, right? So when you slide over, you change in the x. So over here, so x becomes x plus a. So this tells you that you move to the right by the 8 amount. And when you go up and down is the y. So when you move a to the right and you go up, it will be plus b. Okay. And so if it goes down, you minus number, right? So let's go to the example 2. Okay, translate a figure in a coordinate plane. So notice over here it says the coordinate xy becomes x plus 5, y minus 2. What it's saying is that whatever the point you have, you're going to move 5 to the right and go down by 2, right? Because again, y is up and down, so you're going to go 5 and down by 2, right? That's what it says, okay? So -4, when you go 5, so you add 5. So -4, so you can do it by geometry, okay? By look at figures, so you go 5. So let's do A. So you go 1, 2, 3, 4, 5, and go down 1, 2. See that? So 5, 2. B, again you go 5, 2. Point C, you go 5, 2. D, you go to the right 5 and 2. Okay? So again, that's what it's saying. Okay, so you can do it if you do it by geometry, you can count the squares. You just from here, just go 1, 2, 3, 4, 5, 1, 2. Okay, and that's how you locate a point. Or you can do it by coordinates. Okay, you just go and add. So -4 plus 5, right? You have to plus 5 for x. So -5 plus 5, you get 1. 3 minus 2, you get 1. Okay, and again, see, this is your point 1, 1. Now for point B, you start with -2, right? And you plus 5. Right, every point you plus 5, you get 3. -1 plus 5, you get 4. -3, you plus 5, you get 2. Okay? Now for the y, you have to minus 2. So 4 minus 2, you get 2. 1 minus 2, you get -1. 1 minus 2, you get -1. Okay? So you can do it by algebraically, or you can do it by geometrically. Okay? So make sure you know how to do both ways. Okay? So that way, it depends on the situation, you can use either method. Okay. Let's go talk more about reflection. So translation is much easier. Translation is very easy. Now reflection is as in this lesson, when a reflection is shown in a coordinate plane, the line of reflection is always x-axis or y-axis. Okay? Now just be aware that the line of reflection does not always have to be x-axis or y-axis. Sometimes the line of reflection be like diagonal, and that would make things really complicated. Okay? In that case, probably easier if you if you have graph paper, it would be a lot easier just go and count the squares. Okay? But anyway, so right now we're just kind of doing it by reflect over the coordinate axes. Now, when you reflect over the coordinate axis, when you flip it over, notice x stay the same, right? The y become opposite. So when you're doing the reflection over x-axis, when you flip over the x-axis, the x stay the same, but y become opposite. Okay? And same thing, if you reflect over the y-axis, when you flip over this way, notice when you flip over, the y stay the same, right? Like this point, when you flip it over to here, the y stay the same. So the x becomes opposite. So in geometry, you can count the squares, but in algebra, you kind of have to know what to multiply. Okay? Again, if you don't remember, just draw out a picture and think it through. Okay? So you can look at a picture. Okay? From here to here, the y stay the same. That means x becomes opposite. Over here, the x stay the same. So that means y become opposite. Right? So again, x stay the same. The y become opposite. Okay? Over here, the y stay the same. The x becomes opposite. So that's for reflection. Okay, let's go to page 274 and example 3. Okay, so woodwork. Okay, you are drawing a pattern for wood design. Okay, use a reflection of the x-axis in the x-axis to draw the other half of the plane. Okay, so this is what you have. So again, when you're doing a reflection, everything just flip it over, right? So you can just count the squares. See over here, it's go 1, 2, right? So when you flip over, you just go down 1, 2. See that? And this over here, again, is from it. Again, look at the axis. Just count the squares. So go 1, 2. So you just go opposite direction, 1, 2. Or you can use a coordinate. Okay. And this point is 1, 2, 3, 4. So you just go opposite direction. Go 1, 2, 3, 4. Okay. And just draw it. Okay. Again, if you use geometry, when you reflect over, the x stay the same. Okay. The x stay the same, y become opposite. So this point, again, x stay the same, y become the opposite. Okay. Over here, x stay the same, y become the opposite. Okay, so x stay the same, y become opposite. Now you say, wait a minute, this is positive, negative, how come they're the same? Well, 0 and negative 0 are the same, right? So that's why you still have a 0, okay? So again, x stay the same, y become opposite. X stay the same, y become the opposite. So all these are points. So you can do it by algebra, and then you plot each of the point, or you can do it by geometry by counting the squares. Okay. Okay, now let's go over rotation. Okay, rotation in this lesson. Okay, in this lesson, if a rotation is shown in a coordinate plane, the center of rotation is the origin. Okay, again, it does not have to. Okay, but when the rotation is not in the origin, it makes things complicated. So keep things simple. They kind of just use the point of rotation, the center of rotation at 0. Okay. And the angle of rotation is formed by ray drawn from the center of the rotation to corresponding point on the original figure in its image. So the angle of rotation is you just draw from the center of the rotation to any point. Okay, so from here you draw to here, and from here you draw to the image. And the angle you form, that would be the angle of rotation. Again, you can choose any point. You can choose like here, so you have to draw from here and draw from here. Again, that will give you 90 degrees. Okay? But it's more obvious when you draw to the straight edge. Okay? And here's another example of, so this way is clockwise because that's the way that the hands on the clock rotates. Okay? And counterclockwise means going against the direction of the hands on the clock goes. Okay? So again, you choose any point. So from here you choose any point, and from here you choose the point to the corresponding point on the image, and you can use a protractor to measure. Okay? Now it says, notice that rotations preserve the distance from the center of rotation. So segments drawn from the center of rotation to corresponding points on the figures are congruent. So in other words, what it's saying is that the distance will stay the same. So all the one that we covered so far, everything will stay the same. Okay, only the position will change. The size, the shape will stay the same. Okay, so again, the transformation will not change the size or the shape of your object. Okay, identify a rotation. So on page 275, it says graph AB and CD, okay, whether CD is rotational AB about the origin. If so, give the angle and the direction of rotation. Okay, so the way you can tell is, see, remember we did the slope, right? So when you graph, okay, so when you're doing the slope, right, notice the slope equal to, for example, you give you a number, right? So example, if the slope equal to -2/3, okay, then the slope of a perpendicular line would be negative reciprocal, so it would be 3/2, okay? So if you notice, the number got flipped, got switched, and the sign become opposite, right? So when you have the rotation about point of origin, you can use this concept. So if you notice the point A, the coordinate is -3, 1, right? Now if you notice the point C, the coordinate is 1, 3. So if you notice again, see the number got switched and become opposite, just like the slope. See the slope? Right, see the number switch, right? 2 and 3 becomes that, and the sign become opposite, right? So you can think of it as a slope, because in this case, the slope equal to y over the x, right? So think about slope equal to y over the x, so it'd be 1 over -3. Okay, and notice the slope over here is y over x equal to 3 over 1. See, so it's a negative reciprocal. Okay. So to figure out the rotation about the point of origin, okay, what you do, you switch the coordinate and make one of the coordinate opposite, okay, and you have to figure out which one is going to be opposite, okay, because if you go this way, this becomes opposite, okay. If you go the opposite, the other direction, then the other number can be opposite. So just be aware of that, okay. So watch out. The easier thing to do, just go and use graph paper, and it become more obvious. The algebra sometimes is kind of a little bit harder to do, okay? But if you use a graph paper, it's a lot easier, okay? So again, if you graph it out and you draw the line, and you can measure, that's 90 degrees, right? And draw here, measure, that's 90 degrees. So the angle, this angle, so angle AOC is equal to BOD, see that? So again, you have to draw this angle. So this angle and this angle are equal, therefore this is a rotation. And it's a 90 degrees clockwise rotation. Okay. Now, if you try this one over here, okay, so you can try, so you can draw you can draw this and draw, so you try to find the angle AOC, so it's the AOC, and you can measure that, and then after you go BOD again, so it's all messed up. So this is not a rotation. Okay. Another we can do it by just rotate, right? Okay. Okay. You can see that if you just sort of 90 degrees, you can kind of move an object. Okay. So again, rotation is a little bit harder to do. Okay. But if you can use a graph paper, it will help a lot. Okay, let's go to example 5. Verify congruence. The vertices of triangle ABC, okay, so over here, are 4, 4, 6, 6, 7, 4. The notation xy becomes x plus 1, y minus 3. That means you're going to move 1 to the right and go down 3, right? So plus 1 means you go 1 this way, right? Minus 3 means you go down 3. So from here you go 1 over, down 3. Right? From here you go 1 over and down 3. 1 over down 3. Okay? So describe the translation of ABC to DEF. Show that triangle ABC is congruent to DEF. To verify that translation is a congruence. Okay. So solution, you can see that AC equal to DF equal to 3. So AC equal to DF equal to 3. So that is that, right? And it says use the slope AB parallel to DC. So AB parallel to DC. Now, the slope are the same, right? Because notice the slope is you go up 2 over 2, go up 2 over 2. Okay? So slope equal to 1, right? Again, slope is y over x. So when you go, so slope equal to 2 over 2. This one, the slope equal to 2 over 2. So they are same slope. So you can draw this, extend this, and make it into parallel line. And whenever you have parallel lines, all the angles are congruent. This would be corresponding angles, and this would be corresponding angles. Okay, and if two angles are congruent to the same angle, then they are congruent. Okay, and next you can see that so you can also, okay, so if you extend that, so you can give you the angle BAC. So BAC is congruent to that because of corresponding angles, and this is congruent to angle angle G, so therefore they are congruent, right? So BAC is congruent to EDF. Okay, so these two are congruent. The next, use the distance formula. Okay, AB, so A squared plus B squared equal to C squared. So this is equal to 2 square root of 2. Again, you can use distance formula, and you should know that already. If you don't remember, you have to go back and review. Okay, so this would be 2 square root of 2, right? Because A squared plus B squared equal to C squared. And since they are congruent, so you do the 2 hash mark. So you can see the triangles are congruent by SAS. Okay. Now, because the two triangles are congruent, the translation is a congruence transformation.